Lesson 65, writing equations of parallel and perpendicular lines. Okay, so it says parallel lines do not intersect and have the same slope. Okay, the same slope. Whenever we're talking about writing equations, which is what we're talking about today, you should know which part of the equation is the slope. So you should know y equals mx plus b. This is our slope-intercept form, where m is our slope and b is our y-intercept. Okay? So it wants us to start by graphing these two equations. So if I'm going to graph this first equation, I'm going to start at -1 on my y-axis, because that's my y-intercept. So on the y, I'm going to go down 1, right here. From this point, I'm going to go 3 over 1. This is rise over run. So I'm going to rise 3, 1, 2, 3, run 1. Rise 1, 2, 3, run 1. I can do that as many times as I need to get myself a nice line. Okay, or I can do the opposite, go down 3, left 1. You have to do the opposite both ways. Okay, I'm going to do my best to make a nice straight line. I'm not very good at that. Okay, so the next one is at positive 2 for my y-intercept, so that's where I'm going to start. 1, 2. From there, I'm going to travel 3 over 1, so I'm going to go up 3 over 1. 1, 2, 3. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Again, I can do the opposite. Down 3, left 1. Down 3, left 1. Whoops, did I get off 1? Nope, I didn't. Down 3, 1, 2, 3, left 1. And it looks like they're going to intersect because I was bad at drawing my line, but they, in fact, are not going to intersect. Okay, because they should be straight lines and they're not because I have a shaky hand. So you can see here that I have the same slope of 3 over 1, and that gives me two parallel lines. Now, it says to determine if the equations represent parallel lines. If they do represent parallel lines in my equation, once I get y by itself, the slope will be the same. Okay, so parallel lines, you need to write that down. Parallel lines have exact same slope. Very, very important. Exact same slope. So, this equation already has y by itself, right? So I have y equals mx plus b, where m is my slope. So I can see right now that if these lines are going to be parallel, this equation has to have -2/5 as the slope. So let's see if it does. To get y by itself, I'm going to start by subtracting 2x from both sides. Those will cancel. I'm left with -5y equals -2x plus 10. Divide by -5 on both sides. Cancels. I get y is equal to -2 over -5 gives me a +2 over +5. Because negative and negative gives me a positive x, and then 10 over -5 is going to give me a -2. Alright, so my slope here is that 2/5. Are these the same? That's the question. No, the answer is no, absolutely not. They are opposites. They have to have the exact same slot, the exact same sign, and the exact same numbers. Okay, doesn't have it. So this one is no, absolutely not parallel lines. Write an equation in slope-intercept form for a line that passes through 2, -4 and is parallel to the line with the equation y equals -3x plus 1, which is already in the form of y equals mx plus b. If I want them to be parallel, what has to be true? I hope that you're thinking that they have to have the same slope, because that's exactly what I need. I need to have a slope of -3. I didn't mean to take that x, just -3. Okay, for this other one. And I know that it passes through 2, -4. So if I have a point and I have a slope, I can use my point slope formula, which is y minus y sub 1 equals m times the quantity of x minus x sub 1. They give me a point of 2, -4, which I can label x1, y1, and I know my slope, m, has to be -3. So I'm just going to plug everything in. I have y minus y sub 1 is -4 equals m, which is -3, x minus x sub 1, which is 2. Okay. At this point I can simplify, so I'm going to say that double negatives gives me a positive, so I have y plus 4 equals, this -3 has to be distributed, so I have -3x, -3 times -2 is plus 6. To get y by itself, I'm going to subtract 4 from both sides, so I get y equals -3x, 6 minus 4 is plus 2. Are these two lines, these two equations, I'm going to write the other one up here, y equals -3x plus 2, are these two equations parallel to each other? They have to be. I used the slope, okay, as long as I didn't make a mistake here somehow, they have to be parallel because they have the exact same slope of -3. Perpendicular lines are two lines that intersect at a right angle, okay? So, they want us to graph these. So I'm going to start with +3 on the y, 1, 2, 3. From there I'm going to go -1, which is down 1. So I'm going to go down 1, run 2. Remember, I can only take my negative with one of them, and I like to take it with my rise or fall so that I know whether I'm going up or down, and I always run to the right, okay? So I'm going to go down 1 over 2. A couple more times here. Okay, I could do the opposite and go up 1, left 2. So I can go all the way across. And I'm not going to draw my line yet. I'm going to use a tool to do that in a second. On this one, I'm going to start with my y-intercept again, which is -5. So I'm going to go down 5. 1, 2, 3, 4, 5 right here. And from there, I'm going to do my slope, which is 2 over 1, which is rise over run. So from this point, I'm going to rise 2, run 1. I didn't mean to put a point there. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Okay, I could also fall 2, go left 1. Alright, so now I'm going to use my line tool here, and I prefer to be correct and have that the arrows go both directions because it's a line, it's going to continue on, and I'm going to go from this point through all of those points, and for the other line I go from here through all of those points, so that I have a much better graph than what I showed you when I did it by hand on the parallel lines. You can see here how these two lines meet at, whoops, I didn't change back to the pen tool. Okay, you can see how these two lines meet at a right angle, which makes them perpendicular. Did I say what makes, okay? It doesn't say. Okay, so what do you notice about the slopes of these two lines that make them perpendicular? They're not the same, okay? In fact, for lines to be perpendicular, for you to have perpendicular lines, your slope must be opposite reciprocals. Okay, notice that they're opposite sign. One is positive and one is negative, and that 1/2 is the reciprocal of 2, or 2 is the reciprocal of 1/2. Okay, opposite reciprocals for perpendicular lines. Determine if the lines passing through the given points are perpendicular. So they give me 2 points. And all I care about when I'm trying to figure out whether lines are perpendicular or parallel is their slopes. That's all that matters to me. So I can use my slope my slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I'm going to do line 1 first, so I'm going to label it, whoops, x sub 2, y sub 2. This is 0.1, which is why I have my sub 1s. This is 0.2, which is why I have my sub 2s. So the slope of line 1 is equal to y sub 2, which is 1, minus y sub 1, which is 5, over x sub 2, which is 2, minus x sub 1, which is 3. So I have 1 minus 5 is negative 4, over 2 minus 3 is negative 1, which gives me a slope of 4. For them to be perpendicular, I need line 2 to be the opposite reciprocal. So since this one's positive, I need line 2 to be negative and the reciprocal of 4, which is 1 over 4. This is what I need. Okay, opposite reciprocal of this first line. Let's see if we get it. So the slope of line 2 is equal to, I'm going to label these also, x sub 1, y sub 1, x sub 2, y sub 2. So y sub 2 is 3, minus y sub 1, which is 2, over x sub 2, which is 6, minus x sub 1, which is 2. So I have 3 minus 2 is 1, 6 minus 2 is 4. I want you, in your notes, to write whether or not these two lines are perpendicular. You figure that out. Write an equation in slope-intercept form for the line that passes through 2, 1 and is perpendicular to the line with this equation. If it's perpendicular, I'm worried about the slope, right? Perpendicular lines have opposite reciprocal slopes. Again, they're giving me a point and they're telling me the slope. So I'm going to use my point slope formula, which is y minus y sub 1 equals m times the quantity of x minus x sub 1. I'm going to write my 1, 2, and I'm going to label it x1, y1, and I know that this is my m. So I'm going to plug that information in. Y equals y sub 1, which is 2, not equals. Let's erase here. Maybe we'll erase it. Let's start that over. Okay, so y minus y sub 1, which is 2, equals m, which is 1/6 here, but I need it to be the opposite reciprocal of this m. So the opposite means it's going to be a negative, and the reciprocal of 1/6 is 6 over 1, or just 6. X minus x1 is 1. So now I can simplify. I'm going to distribute that negative 6 to everything on the inside. I have y minus 2 equals negative 6x. Negative 6 minus times negative 1 is positive 6. Add 2 to both sides to get y by itself. And I get that y is equal to negative 6 plus 8. Final answer. Alright, it says use the slopes of the line segments to show that ABC is a right triangle. Well, first of all, if this is a right triangle, that means it has one right angle. So, really quickly, I want you to write down which angle of this triangle looks like it's probably a right angle. I hope that you chose angle B. Okay, this is the angle that we want to know, is this a right angle? So we're going to find the slope of this line and the slope of this line. And they've given us these coordinates. So I have that A is going to be 1, 2, 3, 4, 5, 6, negative 6. 1, 2, 3, 4, 5, 6, 7, 8. Negative 6, 8. B is going to be 3, 1. C is going to be negative 1, 2, 3, 4. And negative 1, 2, 3, 4, 5, 6, 7, 8. You should be able to use this information, okay? We want to know the slope of AB, and we want to know the slope of BC. So how can I find the slope using 2 points? I want you to do that on your own paper. I need you to give me your best effort, and if you try and you think you got it wrong, then I want you to write a note to ask in class tomorrow so we can do it on the board together. Okay, so do your best. Look back at the other example that had a problem like this one. Remember, for it to be perpendicular, we need opposite reciprocal slopes. So that's all I have for you. I hope that you have a good night and that you've taken good notes. I'll see you in class tomorrow.